Hello everybody, I am Ben from Team Panic, and today we're going to be looking at controlling a combat robot completely with Arduino, so without any radio control gear at all, only stuff that you build yourself. Now before we get too far into this, I would like to say thank you to JLC PCB for sponsoring this video, but we'll talk more about them in a little bit. Now, for those of you who I might know, I've kind of talked about it a little bit in the past. I have had an Instructable up on Instructable for a couple of years now, looking at how you can create an RC link between two Arduinos that you can then use, one to control a robot and one to fight a robot, or to have inside the robot and actually run the motors and everything. So this has been out for a little while. I've got the Instructable out there, and I thought now it's about time that we did an actual video on this, because I've got a few small updates that I'd like to do for the Instructable. It's not enough to produce another Instructable, but considering I've never done a video on this before, I thought it was about time that we do that. So let's take a look at the kind of different iterations. This guy here, like I said, is the very first one I ever did. It's on perf board, it's all hand soldered, and it's a bit messy. The second one I ever did was this guy. This is the one that the Instructable was on. So there is a custom PCB in through the middle here, but everything is hand soldered. Everything else is hand soldered, I should say, and everything is hard soldered with pins. This was a bad idea for a number of reasons, but we'll talk about those a little bit more when we get into the component choice stuff. But needless to say, like if this H-bridge dies, then there is no way to get this back off again, which means you can't swap that back out, which means that this whole stack just needs to get thrown away. There is nothing wrong with the Arduino or the NRF on this stack, it's just this motor driver is dead, and therefore all of this can't be used, or at least can't be used in a combat robot. This one here, you can see there's actually the red board in underneath, and then there is another H-bridge hastily hot glued on top. So I've basically, had one board die, couldn't remove it, and just added a second board straight over top of it, because in the robot that this was in, it actually had enough weight to do that. I've since retired this board because the perf board ended up splaying everything out and making it just a lot bigger than it needed to be. So finally we move on to this guy. This guy is the new PCB that I've designed, running different components, better components, and also running the H-bridge up on wires, so that if this H-bridge ever dies, I doubt it will, but if it does die, then I know that I can easily swap that out, which is good, because it means this whole stack can be reused if the H-bridge does die. So, component choice. This is where a big jump in my understanding has happened over the past couple of years. So these here are all the electronic components that you need for the receiver module to drive two motors. So we have the Arduino in the first column, the NRF, which is the communication chip in the second column, a 3.3 volt regulator which powers the NRF, and then you need a H-bridge, which is the thing that actually powers the motors. So over here in the Arduino, so these are Arduino Pro Minis, which are one of the smallest forms of Arduino, or at least smaller, cheaper forms of Arduino. You can get these in two different flavors, which is the 328 and the 168. Yes, 328 and 162, I think it is. So those are just the actual model number of the chip on each of the boards. It just basically means there is a difference in the amount of memory that each one has, but for what we're doing here, either one of these is going to work perfectly fine. You just need to know which one you have, so that when you go to program the Arduino, you can actually program it with the correct programming settings. So just get any Pro Mini, basically the cheapest ones you can find on AliExpress will do perfectly fine for this job. Just make sure they are 5 volt Arduinos, that's all you need to know for those guys there. Next up is the NRF chip. So this is the communication center for our whole little stack here. So if this goes down, then the whole receiver module goes down, because you can't get signals anymore. So first up, I have a tiny, tiny little NRF chip, which is one that I wanted to use in combat robots, but these things are very, very small, very hard to solder up, and also that tiny little silver cylinder there is the crystal, which is a timing crystal. So All of these communication type modules need some form of crystal so that they can keep an accurate track of time. Without that, they kind of drift off and they stop communicating with each other. So these crystals are very, very important. And this one here is quite open and exposed and it isn't glued down to the board or anything, so I can move that around with my finger, which means that if that gets hit and breaks, then it is going to stop working and the whole board is going to stop working basically. So these things, while they would be a good idea because they are a lot smaller, they have a glaring weakness in them. The original NRF modules that I used in the Instructable are these guys here. These are just one of the cheapest forms of the NRF module that you can find. They have a big old crystal on the side here. That's this little silver pill shaped thing. One thing I did find is when I was using these, I had to hit the back of these 2 points with a soldering iron. That is where the crystal connects down into the board. Just needed to re-solder those just to make sure that that connection is good and solid. Some of the ones that come out of China, those connections aren't the greatest and therefore the whole chip just doesn't work from the get-go. Now, as with the other guy here, this crystal is quite exposed, and in some of these, even if you touch these with a soldering iron and just resolder these joints, pushing the crystal left and right will stop the actual module from working. So these do work pretty well, especially in a non-destructive league. They work really, really well. But if you are putting your robot into a full combat destructive class, then an unlucky shot can wiggle this chip or this crystal just enough to stop the whole thing from working. So I've had 1 or 2 of them die from this, but those have been in really, really big shots that I've taken from a weapon and the robot's kind of bounced around the arena and landed wrong and knocked the crystal. If you can protect the crystal in some way, this type of thing won't happen and you can get away with using the cheaper NRF boards. The way around that is this guy. This is an NRF board, I think from OpenSmart, and this has the best setup of the lot. Not only is it actually the same form factor as this guy, which means it can go into the PCBs that I've designed, it also has an SMD crystal. So that tiny little square there next to my thumb is the crystal, and that is nice and flush with the board, which means that it's not going to get hit as easily as the other 2 types of crystals that we just looked at. So these things are slightly more expensive than the bog standard black NRF boards, but they are absolutely worth it because they can survive quite a lot more hits. And this is the new type of board that I now use in all of my full combat robots. Anything that's going in non-destructive, I just put these guys in. Also, these things are totally fine for controllers because controllers are never going to get knocked around or bashed around. So this chip in a controller is totally fine. In fact, that is what I've got in my controller board here, but we'll talk about controllers in half a second. Next up, you've got a little 3.3 volt module. This is just a 3.3 volt buck converter, I think is what they're called on AliExpress. I'll leave links to all of these things in the Instructable so that you can have a look at all of those. The final line up here is the actual H-bridge modules. So these are what output the power to your motors, and these are the first things to die if your motors get overly stressed. So you need to know what you're putting into your robot and what actually works and what doesn't. So down the bottom here is the original H-bridge that I suggested in the original Instructable. This is a 0.5 amp per side H-bridge, or dual H-bridge, I should say. All of these are dual H-bridges. So this is 0.5 amp per side, and the N20 should be okay on that. N20s at stall are 0.5 amp per side. However, I've found that back EMF spikes, if you run the motors really quickly and then reverse, or get hit and have the motors reversed, do sometimes kill these. So I would suggest not using these guys. They are okay for what they are, but they can be killed relatively easily. The next up here is a 1 amp dual channel H-bridge. So this now has twice the power of the original guy here. And these guys are great. They are a lot smaller, they're a lot lighter, they are just a slightly more expensive. The only problem I've found with these is batching issues. So I'll get a batch of these and they'll be perfectly fine. Everything will work. I'll have 10 of them. All 10 will work flawlessly with no problem. And then every now and again, I'll get a batch and only 1 out of 10 or 1 out of 5 will actually work out of these. So I stopped using these a little while ago when that batching issue just got to be too much for me, and I was kind of spending time soldering these into circuits and then suddenly having them die and not work. So that would be great if they actually worked properly. And look, if you need a slightly smaller board or whatever, these guys do work okay if you get ones that actually work. Then finally here we have a 1.5 amp per side H-bridge, dual channel H-bridge. This is also good because it's got caps on the input, which means that the power rail bounce that your power rail sees from your motors gets smoothed out a little bit. It's also got some back EMF protection on it as well. So this board is quite robust. It's a little bit heavier and about the same cost, I think, as the 1 amp board. So these guys are what you want for this application. I have moved all of my combat robots over to these 1.5 amp boards. These things are bulletproof in a combat robot. I have never had one of these things die. Even though I have got them sat up on extra wires just in case they do die, still have not had that happen to me yet. So these guys are the ones that I would recommend. For the controller, there is 2 extra pieces that you need, and you can ignore the H-bridge. So you've got your Arduino, you've got your NRF, and you've got your 3.3 volt converter. You also then need a joystick, which these guys are just sold as Arduino joysticks, and a potentiometer. So the potentiometer is to control a weapon of some kind, either through a servo or through a brushless ESC into a brushless motor. So to connect these components together, you have a couple of options. One, you can direct solder them using just some jumper wires like I've done here. This can be useful if you need to save a lot of weight. This here is for my flea weight, which is 75 gram combat robot. However, I would not recommend doing this because one, it's kind of stressful as you need to make sure that like at every step of the way you're actually soldering the right thing to the right thing. It's also very fragile and easily broken. This one here is broken because some of the wires have come off just in combat in general. So yeah, you can do it that way, and if you want to do it that way, jump down to the Instructables where you'll find a set of wiring links, and you can just wire this up exactly like that, following those instructions. But like I said, this will take you longer and it will also be more stressful, and at the end of the day you end up with a lighter but weaker product. So what we're going to be focusing on is this. This is a custom PCB designed to connect between a Pro Mini and an NRF chip. So this has got a couple of steps in the process that you need to follow just to make sure that everything goes on correctly. So we'll have a look at those, but first we'll have a look at actually ordering these, because getting your own PCBs or your own copies of these PCBs is pretty easy. Simply download my Gerber files from the Instructables link and then jump on over to JLC PCB and hit quote, get a quote. Now, add my Gerber files in here, so I'm just going to use the receiver boards. It will take a second to load up, and you have a whole bunch of options down in underneath here. Once this thing has loaded in, a lot of these will auto set themselves, and it should show you a kind of preview of the design, which is this one here with my logo and the word panic in there as well. It should automatically preset a bunch of these things, and you can leave these pretty much exactly as they are. I would suggest going up to 10 PCBs, and if you are really worried about weight, you can drop the PCB thickness down a little bit, but the default will work totally fine, and you're only going to save maybe a gram at the very most by dropping down the PCB thickness. So the good thing about JLC PCB, these guys do pretty quick PCB manufacturing, and also they do 10 boards for a couple of bucks, so that is really good. So yeah, there you go. That's kind of my suggestion for the setup for these things. Like I said, if you're really worried about weight, you can change that. If you mess around with this stuff too much, then they will change. The $2 is mostly for kind of the default settings and stuff, but for this exact board, we don't really need anything other than the default settings. So then we can go safety cart, and of course go through and log in and do all of that kind of stuff to finalize out that purchase. Then they'll arrive in a box like this one. So in here, I mean, I've just thrown these back in here because I've been testing with these all week, but you will then get your PCBs that you can then go ahead and solder up. So we're going to take a look at soldering up the receiver module. The module for the actual controller here is really quite straightforward. You literally just put all of your components in place and solder them up as you would expect. So the Arduino goes this way, the NRF just goes where it's actually shown, and then everything else around here, you need to put your 3.3 volt module in there, just like this, up in there. And then the rest of these are actually optional. So you've got your power and ground over there, which is not optional, but then there are 3 switches here which are wired up to the Arduino, and then there's a potentiometer setup over here, which is for your throttle, for a thumbstick, for a weapon, and another potentiometer here, which is for a trim pot to trim the values coming off of this. But these 2 things get read separately and then added together in code. So that code you can write and change for yourself. At the moment, the code that I have that I've put up on Instructables only takes in the value of the actual throttle pot. But if you want to add a trim pot, you can add the trim pot in there and then add your own code to make that do whatever it is you want to do. So this guy is pretty straightforward in the soldering department. These guys here, I will say these are just a switch directly to ground. So if you use those, you need to put internal pull-ups on those resistors, and hopefully in the code I will remember to put commented out lines that set up each of those switches so that you can actually use those correctly and set those up so that you can use them to trigger any events that you want to trigger inside your main program. So there you go. That is the controller board. It's pretty easy and quick to set up. So now we're going to go ahead and have a look at the receiver module, because I've designed this to be as compact as possible, which means that there are a couple of steps that we need to take in a very set order so that this thing actually comes out correctly and that you can get to all of the solder pads that you need to get to. So this is pretty easy to put together, but I am doing it all on camera because you kind of want to follow some exact step orders. In terms of tools to do this, the only things that might be a little bit different from any regular soldering stuff, so I mean, helping hands, wire strippers, a soldering iron, and a pair of side cutters and some solder, a pretty standard soldering gear. The only thing that you might need that is not in that list is this, which is a fine bladed screwdriver, just like this guy, and we'll get onto what we do with that in just a second here. So, first up, we are going to need to connect the Arduino Pro Mini up and get its pins ready to go. So this doesn't go on first, but we do need to get everything on here set up, because once we have this soldered onto the board, we can't really make any changes, or we can't easily make changes to what's soldered to the pins of this Pro Mini. So we need to make sure we've got everything we want in this Pro Mini now, and then we can solder it to the board and leave it there for good. So when you're soldering this guy up, it needs the ground and raw pins on this side, pins 13, 12, 11, and 10 on this side, and then pin 9 on this side need a pin header like this guy to then connect them down into the circuit board. All of the other pins cannot have pin headers in them, so realistically you need a 2-pin header here, a 4-pin header here, and a 1-pin header here. Normally I use 2, I connect 9 and 8 just to give this a little bit more stability when I'm going through and soldering it. And I also put some extra pin headers up here, but I don't solder them in. So you will see that in just a second. So let me cut some pin headers down and we'll have a look at this. So I've just dry fit these two boards together, and it really at this point in time doesn't matter which way around the Arduino is on, because we're not going to finally solder everything in place. All we're going to do is solder the actual pin headers into the Arduino at this point. Once we've got all of the pin headers that we need soldered up, so once again that's the ground, the raw, 10 through 13 and 9, then we can lift this Arduino off and we can solder up the other pins that we need to contact to things. But these are the only pins that are going to go through into our circuit board. So I'm going to quickly solder these up, and to do that I'm literally just going to hold the green circuit board, the green PCB, in my helping hands here, and then I am going to solder all of these pins and try my hardest not to touch the Arduino Pro Mini. But the good thing about having everything set up like this is that we know that once we've soldered all these pins in, we should be able to lift this out and drop it back into the same spot, and it shouldn't have any issues with that, because of course it's been soldered in place while sitting on this circuit board. So it knows where it's going to seat back in, and that is really, really good for us. So let's take a quick solder to these, and we'll get right back into it. Okay, so there we go. That is now the Pro Mini with its headers soldered in place. As I said, I had two headers over here just to stabilize the board as I soldered everything else up, but those aren't needed anymore because they're not connecting anything. So we can toss those aside, and you can see in under here, we've got two sets of 2 and a set of 4. Once again, this set of 2 over here is not strictly necessary. Only the pin 9 is actually necessary on here. But once again, I use pin 8 for a bit of stabilization as I'm soldering everything up, and it might as well just get soldered in and stay there, because otherwise it's a little bit hard to get rid of. So the next thing we're going to look at is where the H-bridge board goes. So that gets soldered between pins 2 and pins 5, so 2, 3, 4, and 5. And we're basically just going to connect 2 and 3 to one of the input sets. So we're going to do 2 and 3 to pins in 3 and in 4, and then we're going to set pins 4 and 5 to in 2 and in 1. Doesn't really matter which way around you do these, as long as you connect 2 and 3 as a set to one of these two sets up here, and 4 and 5 as a set to the other set, and then you're good to go. But we don't actually even need to solder this board in right now. All we need to do is solder wires off of these pins, and then we can solder it onto the H-bridge at a later date. So also, if you want to run a weapon off of this same board, then you solder into pin 6, and you can solder just a regular wire into there and then connect that either to the signal port of a ESC, or you can connect that to a servo, and you can drive either a flipper or a brushless weapon off this board. And all of that stuff is done in code, but all you need to know for now is that if you want a weapon on this thing, you need to connect a wire into pin 6. So I'm not going to make you guys watch me solder wires into these 5 connections. I'm just going to take some of this wire that I have lying around and make up those connections. Okay, so now we have the Arduino Pro Mini all wired up with all of its wires coming out of it. So that is now ready to be set aside. So we can set this aside and we can start looking at the NRF chip, and basically it's now a steamroll out to finishing this board up. There is only one little thing left to do, which is where this screwdriver comes in. So I like to remove the spacer blocks here, these little plastic spacers, off of these pin headers on the NRF module, because by removing those you can get this board closer to the actual PCB, and that means that just the whole thing is a little bit tighter in, and you're using less space with your control boards, which is a good thing because Antweights typically don't have a whole lot of space in them. So like I said, you just take a very fine flat blade screwdriver, and you need to basically come in from the side here, jam it in underneath the black plastic between the prongs and lever up essentially, and you'll start to see a little bit of a gap between the actual plastic and the board. Then you go to the other side and do the same thing. And don't worry about being too forceful with this. You can't really be all that forceful with it. Basically, you need to make sure that your fine flathead screwdriver fits between the pins like this, because if it doesn't fit between the pins like that, then you're not actually going to be able to do this. But if it does, then you can jam the screwdriver in there and pull down to lever the black piece up, which, once again, don't worry too much about this, but just kind of go back and forth one side after the other. You slowly peel that up. You can see I'm getting quite a gap now between the circuit board and that piece, and eventually it will get to a point where it just decides it's going to come off completely and it will shoot off the end. Here we go, almost there. Off on one side, I think. Almost there. Can also get in with some pliers. Once it's moved up off the base, you can move in with some pliers and get rid of it. But there you go. So now it's kind of shot across the room. Good idea to be wearing safety glasses when you do this type of stuff, because you did release a little bit of energy when it did that. But there you go. So that is now off and ready to go, which means that when we get to putting this NRF chip in, it can go all the way down and sit as close to the circuit board as possible. This one in particular has an extra logic level divider in underneath the board, so it doesn't get quite as low as the black ones that have the big crystal chip on the top, but this whole board is thinner than those boards anyway, so a little bit of extra air gap here isn't a major deal. And it doesn't really matter too much if this board is on an angle or anything, as long as these pins actually get soldered in the right way around. So this here is the top of the board, the one where the logo for my team sits. This is the top of the board. This is where the Arduino Pro Mini goes in. The NRF board goes in from the underside, and there is a nice little corner here that shows you exactly where this sits, just like this. So this guy goes in first, and we're going to basically use our helping hands to clamp this side down, just like that. Now that those two things are held together, I can solder up these 8 pins. So I'm going to go ahead and solder up these 8 pins. Once I've done that, we'll clip those down. But first of all, let's solder up those pins. So there we go, the NRF board is now in, and we can then chop down these pins. Now, there is some debate between people who do a lot of soldering as to whether you should chop these pins down before or after soldering them up. Personally, I'm of the mindset of whatever makes your life easiest. So in this case, leaving them long is actually going to make our life easier, because this board comes in at an angle, which means you'd need to cut the pins down at an angle, and yeah, if you mess that up, then you'll either have something that's too long or too short, and you won't be able to get a good solder job on it. So personally, I prefer to leave these ones long, and I'd chop other ones down short as needed, as I said. So now we're going to just chop all these down. These things here do shoot around the room and fly all over the place when you cut them off. So make sure you're wearing safety glasses for this section, just to make sure that your eyes don't get hit by tiny chunks of flying metal. So we're almost done here. There's only 8 of these to do. And if you are worried about the quality of your soldering joints, you can go through after you've chopped down your 8 and just retouch these with a soldering iron just to refresh that solder joint and make that a little bit nicer and a little bit neater. But at the end of the day, that should be fine as is. Now, next up, we're going to actually put the Arduino Pro Mini on this board. So the Arduino Pro Mini goes on this way around. So the button out the back here towards these extra sets of connections, and the section where you program the Pro Mini up through the top here goes out towards my logo, just like that. So we can slide those two together. Then once again, hold them together with our helping hands and solder them up. This is a pretty easy process. You have to come in from the sides here because this NRF board is now pretty close to these pins, but you can come in with your soldering iron from the sides and just touch those out with the soldering iron to get those to solder up. Okay, so this guy is now firmly soldered onto our custom PCB down there. And that means all that is left is the power wiring, or the power wiring and the output wiring, I should say. So first up, we have this little 3.3 volt regulator module. And just above the pins, you should see the leftmost pin here is the V in, middle pin is the V out, and then the final right-hand side pin is the ground pin. And literally that just slots in this way around. So with the big actual power regulator hanging out backwards, out away from everything, that's how that slots in, and it just gets soldered in exactly like that. Now finally, on the bottom of the board here, there are, if we put that guy back in place, there's these 6 connectors in this final corner left on this board. The connectors closest to the Arduino are your power pins, your VCC power pins, and your lower 3 are your ground pins. So you need to use 2 of these to actually bring power into this board, so 1 and 2. So the first 2 I would use to bring power into this board. This is directly from your battery and switch circuit. They go into the first 2 pins. Then you've got 2 pins to use for the powering of your outputs. So this guy here needs power to come through from the battery to the plus and minus points on this board here, if you can see those, just like that, up the top corner there. And also your servo or your brushless motor is also going to need power to come through from this board up into those as well. So if you connect your battery to the first one, then run some wires up for this guy, and then run some wires off for your brushless motor. That will be that. That is going to be it. That is this entire board done. Once you have the Arduino on and the NRF on, there's no real tricks to this. It is literally just soldering the wires into the right spots. So these 4 wires here, those 4 wires there, 2 to 5 into the H bridge, 6 goes out to your weapon, whatever your weapon is going to be. This guy goes in there, and yes, in there, and power and ground, and then you're done. Cool. All right, so that is that all soldered up. Okay, and that is going to be it for this video. Originally, I wanted to go through the code for these guys right now as well, but I have a feeling that this video is getting kind of long, so I'm going to separate the code out into its own section. So that hopefully will come out on Tuesday. If it doesn't, then it will be out next week or the following Tuesday. It depends on how long it takes me to get through all of this edit and then all through the other stuff that I need to be doing. But I will put out a video on the code itself, and I'll kind of walk you through how these 2 things talk to each other and what data is exchanged between the 2 and how you can modify that data to do what you want it to do, whether that be control a servo to get a extra motor in there, to get a flipper in there, to control an ESC, to get a brushless motor weapon in there, or to create your own unique control system so you don't want to use my little joystick idea and you want to use a twist grip pistol grip? Yeah, pistol grip. You want to use and build your own pistol grip controller. I'll be able to show you how to do all of that as well in code. These things are pretty straightforward because a lot of the magic happens in that code because it's all, of course, done on an Arduino, so the code itself is almost infinitely modifiable. It just depends on what you want to do with your own combat robots. Yeah, so there you go. That is it. The pretty small, not the smallest, but a pretty small, very cheap internal set of guts for your combat robots. Anyway, I hope you guys have enjoyed this one, and I will see you in the next video.